Hi everybody, Dr. Pingle here with part 2 of the notebook. We're going to talk a little bit about Pix4D and photogrammetric reconstruction of images taken from a drone. The first thing that you're going to need to do is install the software. So Pix4D is at pix4d.com. It is not free software, but if you can try this for free for I think 10 days or 2 weeks, as long as you sign up for an account. So there's a try for free here. That's going to take you to a page where you are asked to sign up. This is one way to get started. Pix4D is a fairly resource-intensive process, and in fact, all reconstruction like this is quite computationally intensive, as you're going to see. It's definitely okay to give this a shot on your laptop, but just be aware that this may take quite a long time to process. So I'm going to process through the data. You'll get a sense of how long it's likely to take. The actual manipulation part of the scene is not really all that difficult, but it will take your computer some time to chunk through this data. So I've provided a link on the notebook page to download the data. This is a sample data set that you can get. This is actually a query data set that comes with, that Pix4D distributes. But I provided it for you so that it's easy to get a hold of. If you unzip and open up the directory, you get something that looks like this. There's a P4D file, which is the project file. And if you look at the images for this file, what you'll see here are some overhead shots of this quarry. And you could actually go through and put these together with ice. So we could show you how to do that real quick. That's not really required for the notebook, but just in case you're interested in what this looks like, I'll run through the data and I'll give you a quick look. So we're just going to clip through the settings here and let this kind of do its thing. So I'll pause the video while it does the reconstruction. Okay, that reconstruction is done, and it looks something like this. You'll notice that in some cases, as in this one, it says the projection options are unavailable because this panorama was stitched together using planar camera motion. So this kind of motion is where you're sort of taking an overhead shot, point down. This is in contrast to what we did in the earlier one, where I was sort of standing in one spot and moving the camera around. You can imagine that that's sort of drawing this sort of sphere of what I'm looking at, whereas here I'm actually translating the camera and moving it around. So depending on how you create the image, you may limit your projection options. If we crop this image out, we get something that looks like this. We can zoom out a little bit here, or maybe we can't. That's all right. So we're just going to go ahead and I'm going to export this really quickly. Okay. So we'll use that to compare to a little bit later on. Okay, so the real thing that we want to do here is this Pix4D reconstruction. So to get that started, we can either run Pix4D from here, or we could have just double-clicked on this and it would open up. But this will be fine. One of the things, you'll see that window pop up fairly regularly. One of the nice things about Pix4D is that it is updated pretty frequently. So I would say that they give an update almost every, here we go, almost every month or so. So we're looking for this P4D file. So here it is right here. That's the Pix4D project file, not so dissimilar than what you're used to working with project files in ArcGIS. This is what that image looks like, or this is what the flight of the drone looked like. So you can see that it took off and landed. It's hard to tell exactly where it took off and where it landed, but you can see that it sort of flies this serpentine path over what is a quarry underneath. And we're going to be doing a 3D reconstruction of that quarry. Now, this particular one has already been run. Well, actually, in this case, it hasn't. So what we're going to do is we need to do some initial processing, and then we're going to make a point cloud, and then we're going to make a DSM. So the way that it knows where all of these images are is that it's all of these have been geotagged. So when the drone flew over these, it took particular photographs. So if you click on these dots, you can see the photo that was taken at that point. And the GPS on the drone tagged these, or they did some post-processing to tag these, and that's how they know the latitude and longitude of all of these points. They also, by the way, know the altitude, so that's encoded as well. If you look at the ray cloud, you'll see, well, it's not built yet, but this will be there in a second. Once we run this first step, we'll build what's called the ray cloud, where it's going to figure out the sort of fine registration of all of these images, because not only are they at an X, Y, and Z coordinate, but they could also be pointed in any direction. So this is where the software comes in. It has to figure out that. And it also has to make some minor adjustments to the position, because we know that the GPS is not perfectly accurate. It kind of is off by a few meters, and so the software is going to sort of finely register those positions as well. You can run each step sort of independently. So we could do the initial processing and hit go, and then we could uncheck that and do the second step and hit go. Let's take a look at these processes. I'm going to let it run and do all of its thing all at one time, but let's look through the processing options to see what it's doing. So in the initial processing phase, what it's trying to do is it's trying to tie these points together. So you can either do a full key point, or you can do a rapid. And this is where it's sort of looking for common features in each image to glue them together. In phase 2, it's going to build the point cloud. So we have some options up here in terms of how it does that. You'll just leave those alone. You can choose to classify the point cloud, so we can make some judgments about whether it's looking at a building or a tree. I would recommend that you leave that unchecked. It's kind of a time-intensive process. And then we're going to export some things. The LAS you've been used to. LAZ is the compressed version of the point cloud file. PLY we've actually been using for our 3D prints. Actually, we've been using STLs, sorry, but PLYs are another way that we can do that. I'm going to uncheck everything except the LAS file, because we're not going to need all of this other stuff. We're also asking it to make a mesh. So we'll go ahead and do this. They won't turn out fantastic, but it's an okay way to sort of take a look. And I'm going to have you export the PLY, the OBJ, and the 3D PDF. We'll leave these unchecked for now. And then in the DSM, orthomosaic, and index, it's going to use those to create an orthophoto. So we can ask it to make a digital surface model. We can ask it to make an orthomosaic. We can also ask it to make a DTM, but that's really only if we've done a point cloud classification, because remember that a DTM requires that we kind of know the difference between what's ground and what's not. So I'm going to uncheck that as well. You'll also notice that it's outputting some contour lines, so you're welcome to take a look at those. They're probably not going to be of fantastic quality, but you can take a look at them anyway. And then we'll leave this screen alone. The last bit here is the Resources and Notifications tab. So this is going to tell us how much RAM we're using to do this. Now Pix4D isn't incredibly RAM intensive. The more you can throw at this problem, the better. And my suggestion is that you kind of set this to go and kind of leave your computer to do its thing for a while. Make sure that it's plugged in. It's going to be using kind of a fair bit of power. So I will generally leave the RAM kind of pegged pretty high, and then you'll see the number of CPU threads that you've got to put at this, and I can put 4 at it. Computers with bigger processors are going to have anywhere between 2, which is hopefully a little bit rare, and you know, upwards of 30 with the newest processors. You can ask it to send you an email when it's done, which is kind of a handy thing. So go ahead and do that if you want. I'm going to uncheck that, but you might be interested in doing that so that you know when it's done. I'll often take the CPU threads down to 3 or 1 away from the top, just so that I've got extra computing power if I need to do something else with the laptop. If you leave this at 4, there's a good chance that you're going to really kind of max out everything you've got, and then you're not going. The system itself would be kind of unresponsive. So I'll often turn this to to one stop below the maximum, which is what I'm going to do for both of these. I'll hit OK, and I'm just going to let this go and do its whole thing here, and we'll see how long it takes. It's 2:20 now as I record this, and we'll see what it's like when it's done. So we'll just go ahead and hit Start, and it's going to start its work, kind of rolling through this process. And I would estimate that this is going to take anywhere between an hour and 2 hours on this particular machine. So we'll give it a chance to do its thing, and we'll be back in a bit.